So the best part of the lesson today is you already know how to do it. Okay? Yesterday, what did we talk about? Cubics, right? Cubic functions. Like x to the third. That's the cubic function, right? Y equals x to the third. F of x equals x to the third. Well, today is this. Cube root functions. What does a cube root function look like? It's a radical, the little baby 3 on the end of it. So y equals or f of x equals, and then we have x inside, right? Now, if we're talking about transformations, and we are, what does the 3 do to this? All the 3 does is give it its shape. That's all it does. Okay? It doesn't cause a transformation to have it. The cube root, this baby 3, gives it the shape that it has. Okay? Because this is the parent function, right? Of a cube root function. So this cube, this little baby 3 right here, the cube root, gives the function its shape. That's where you start. Okay? So anytime you're talking about transformations today, there's nothing you have to figure out for this one. You just know what shape it is because of that, right? Just the same as this 3 up here doesn't do any sort of transformations. Remember we talked about that yesterday? It doesn't do any sort of transformations to it. It just gives it its shape, its cubic function shape. Okay? So I'm not going to go over all of these because they are almost exactly the same as yesterday's. The only difference is it's not x cubed going on, it's a cube root of x. So if we're talking about inside or outside, what are we talking about being inside or outside of? The root, the radical, right? You know that thing right there is called a radical. Do you know that? Not like in the 60s and you're like, radical, dude. Not like that. No, none of that, okay? But that thing, that form right there is called a radical. In this case, it is a cube root, okay? But we're talking about inside or outside of the radical. So if we have y equals the cube root of x plus 2, where's that going to go? It's going to be a horizontal shift because it's inside the radical, and it's being added or subtracted again, so that'll be a shift. We're going to do something slightly different than yesterday. If it's a horizontal shift, which direction is this one going? To the left. 1, 2, right? Now, do you remember the shape of a cube root function? Excuse me? Do you remember it's like that? Okay. The difference today is that this is not the end. Okay? Now it says, what's the domain and range of that function? Well, what is the domain of this function? How far to the left does it go? Right? How far to the right does it go? So all real. Okay? What's the other way we can write this? You remember this? All real. Okay? That means all real numbers as well. Okay? What about the range of this function? All real. So we can either write our double R, or we can write negative infinity to positive infinity. Okay? Now, remember how when we first talked about the textbook, and I said we're not going to be going in order of the textbook because our plan, the YAG, remember, I don't know if I told you about the YAG or not. The year at a glance, the order that I need to follow to make it most understandable for you guys, that's not the order that the book goes in. So that's why we kind of skip around a little bit. Okay? This book doesn't actually have a cube root section or a cubic section. It's all in one section with all sorts of different roots on it. Okay? So while our focus today is cube root functions, there may be something that shows up like this. Y equals the square root of x plus 1. And especially since we've already done that, I really kind of need you to make sure you know how to find the domain and range of that function. Okay? You need to be able to tell me, first of all, that it shifts up 1. Okay? Vertical shift up 1. But once you know it goes up 1, you need to know that the shape goes like that. And you need to be able to tell me the domain and range of this function. So I want to make sure right now that we remember how to do that. How far to the left does this go? On the axis, how far to the left does it go? To 0, right? How far to the right does it go? All the way. So we can say x is greater than or equal to 0. Or we can say it starts at 0 and goes to infinity. What about the range? How far down does it go? To 1. How far up does it go? So how do I write that? Okay, that works. What's the other way? Exactly. We have to use a y for our range, right? Oh, sorry, thank you. You said it and then I wrote the wrong number. Okay, y is greater than or equal to 1. Okay? There are other kinds of roots. There may be a 4th root or a 5th root. What could you possibly use in case you don't know what those look like? Oh, your calculator. Yay for the calculators. Put it in your calculator. Look at the graph. Say to yourself, how far to the left does it go? How far to the right does it go? That's your domain. How far down does it go? How far up does it go? That's your range. Okay? What's going to be true, though, about a cube root? Its domain and range. Let's do this. Let's do y equals negative cube root of x. So it's going to go through the origin, but it's going to reflect over the x-axis, right? So it'll look like that. What's the domain of this? How far left and right? All real. How far, what's the range? How far down and up? All real. So domain and, is this enough to say the domain and range of all cube root functions are all real? Probably not, right? We need to do a little bit more exploring. But guess what? They are. Okay? When you see the cube root, you know it's going to be all real. There are some exceptions to that. We're not going to talk about them today. Okay? Do you have any questions about this? Okay? The problems you have to do tonight says graph the function, identify the domain and range of the function. Do you see how carefully I graph these? And by carefully, I mean not really that carefully, right? I did go up one. I was real clear about that. And then I just kind of went zhunk because I knew it goes zhunk, right? When I drew this one, I knew it went to the left too. So I was clear about that, where it crosses. But then I just kind of went zhunk. And then this one, I knew it went through the origin because there's no any sort of shifts. But then I just went zhunk. Okay? So you are allowed to do that as well. I'm giving you permission to do that. You don't have to always say it like when you're graphing. You can if you want, but you don't always have to. Okay? Airplane sounds are also fine. Okay? So like I said, the first section, it says to graph it and identify the domain and range. That's what we just did right here. The second section in your homework problem says describe the transformations and then graph each function. So basically it's saying it'll tell you f of x equals the cube root of x, g of x equals negative cube root of x plus 1. So what are you going to say on that one? So you're going to say horizontal shift 1 to the left reflects over the x-axis. Okay. Now, a lot of you have gotten into a really good habit of saying that your transformations from left to right, because really, any sort of reflections, they really have to come first. Okay. It really does matter what order these go in. So if you'll go left to right, I think that'll make it a little bit easier to help you remember everything especially. Now, the only other thing that shows up a little bit on your homework that some people today have had just a little bit of issue with is that they've forgotten what I've told them last week. So I'm just going to remind you real quick because I know as soon as I remind you, just like it did for them, as soon as I reminded them, then they remembered and it was fine. Okay? What about if it's something like this? Y equals x plus 2 to the 1/3 power. Oh, that's the same as the cube root of x plus 2. Remember that exponent? The top is the power, the bottom is the root. Well, if it's a cube root, that's what it looks like. So this isn't really any different. There's no different rules for transformations for this as there is for this. There's the same rules. Okay? Keep in mind that if you struggle with any of the transformations, remembering which direction to go, on page 305 in your book, there's a really pretty chart that will be helpful if you need to look at that. I'll show it to you real quick, just so you know where it is. It's at the very top of the page. Right up here it says core concept, and it talks about the different translations, shifts, stretches, things like that. Okay? Work together if you would like. Quietly. Stay focused. If you stay focused, I think you have time, or I'm positive that you have time to finish this before the end of the period. Are there any questions?